Lesson 2. Protons, Neutrons, and Electrons. How atoms differ. Reading guide. Key concepts. Essential questions. What happens during nuclear decay? How does a neutral atom change when its number of protons, electrons, or neutrons changes? Vocabulary. Atomic number. Isotope. Mass number. Average atomic mass. Radioactive. Nuclear decay. Ion. Inquiry. Is this glass glowing? Under natural light, this glass phase is yellow, but when exposed to ultraviolet light, it glows green. That's because it is made of uranium glass, which contains small amounts of uranium, a radioactive element. Under ultraviolet light, the glass emits radiation. The parts of the atom. If you could see inside any atom, you probably would see the same thing: empty space surrounding a very tiny nucleus. A look inside the nucleus would reveal positively charged protons and neutral neutrons. Negatively charged electrons would be whizzing by in the empty space around the nucleus. Table 2 compares the properties of protons, neutrons, and electrons. Protons and neutrons have about the same mass. The mass of electrons is much smaller than the mass of protons or neutrons. That means most of the mass of an atom is found in the nucleus. In this lesson, you will learn that, while all atoms contain protons, neutrons, and electrons, the numbers of these particles are different for different types of atoms. Different elements, different numbers of protons. Look at the periodic table on the inside back cover of this book. Notice that there are more than 115 different elements. Recall that an element is a substance made from atoms that all have the same number of protons. For example, the element carbon is made from atoms that all have 6 protons. Likewise, all atoms that have 6 protons are carbon atoms. The number of protons in an atom of an element is the element's atomic number. The atomic number is the whole number listed with each element on the periodic table. What makes an atom of one element different from an atom of another element? Atoms of different elements contain different numbers of protons. For example, oxygen atoms contain 8 protons. Nitrogen atoms contain 7 protons. Different elements have different atomic numbers. Figure 11 shows some common elements and their atomic numbers. Neutral atoms of different elements also have different numbers of electrons. In a neutral atom, the number of electrons equals the number of protons. Therefore, the number of positive charges equals the number of negative charges. Reading check. What two numbers can be used to identify an element? Neutrons and isotopes. You have read that atoms of the same element have the same numbers of protons. However, atoms of the same element can have different numbers of neutrons. For example, carbon atoms all have 6 protons, but some carbon atoms have 6 neutrons. Some have 7 neutrons, and some have 8 neutrons. These 3 different types of carbon atoms, shown in Table 3, are called isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. Most elements have several isotopes. Protons, neutrons, and mass number. The mass number of an atom is the sum of the number of protons and neutrons in an atom. This is shown in the following equation. Mass number equals number of protons plus number of neutrons. Any one of these 3 quantities can be determined if you know the value of the other two quantities. For example, to determine the mass number of an atom, you must know the number of neutrons and the number of protons in the atom. The mass numbers of the isotopes of carbon are shown in Table 3. An isotope often is written with the element name followed by the mass number. Using this method, the isotopes of carbon are written carbon 12, carbon 13, and carbon 14. Reading check. How do two different isotopes of the same element differ? Average atomic mass. You might have noticed that the periodic table does not list mass numbers or the numbers of neutrons. This is because a given element can have several isotopes. However, you might notice that there is a decimal number listed with most elements, as shown in Figure 12. This decimal number is the average atomic mass of the element. The average atomic mass of an element is the average mass of the element's isotopes, weighted according to the abundance of each isotope. Table 3 shows the three isotopes of carbon. The average atomic mass of carbon is 12.01. Why isn't the average atomic mass 13? After all, the average of the mass numbers 12, 13, and 14 is 13. The average atomic mass is weighted based on each isotope's abundance. How much of each isotope is present on Earth? Almost 99% of Earth's carbon is carbon 12. That is why the average atomic mass is close to 12. Reading check. What does the term radioactivity? More than 1,000 years ago, people tried to change lead into gold by performing chemical reactions. However, none of their reactions were successful. Why not? Today, scientists know that a chemical reaction does not change the number of protons in an atom's nucleus. If the number of protons does not change, the element does not change. But in the late 1800s, scientists discovered that some elements change into other elements spontaneously. How does this happen? An accidental discovery. In 1896, a scientist named Henri Becquerel, 1852 to 1908, studied minerals containing the element uranium. When these minerals were exposed to sunlight, they gave off a type of energy that could pass through paper. If Becquerel covered a photographic plate with black paper, this energy would pass through the paper and expose the film. One day, Becquerel left the mineral next to a wrapped, unexposed plate in a drawer. Later, he opened the drawer, unwrapped the plate, and saw that the plate contained an image of the mineral, as shown in Figure 13. The mineral spontaneously emitted energy, even in the dark. Sunlight wasn't required. What was this energy? Radioactivity. Becquerel shared his discovery with fellow scientists Pierre and Marie Curie. Marie Curie, 1867 to 1934, shown in Figure 14, called elements that spontaneously emit radiation radioactive. Becquerel and the Curies discovered that the radiation released by uranium was made of energy and particles. This radiation came from the nuclei of the uranium atoms. When this happens, the number of protons in one atom of uranium changes. When uranium releases radiation, it changes to a different element. Types of decay. Radioactive elements contain unstable nuclei. Nuclear decay is a process that occurs when an unstable atomic nucleus changes into another, more stable nucleus by emitting radiation. Nuclear decay can produce three different types of radiation: alpha particles, beta particles, and gamma rays. Figure 15 compares the three types of nuclear decay. Alpha decay. An alpha particle is made of 2 protons and 2 neutrons. When an atom releases an alpha particle, its atomic number decreases by 2. Uranium-238 decays to thorium-234 through the process of alpha decay. Beta decay. When beta decay occurs, a neutron in an atom changes into a proton and a high-energy electron called a beta particle. The new proton becomes part of the nucleus, and the beta particle is released. In beta decay, the atomic number of an atom increases by 1 because it has gained a proton. Gamma decay. Gamma rays do not contain particles, but they do contain a lot of energy. In fact, gamma rays can pass through thin sheets of lead. Because gamma rays do not contain particles, the release of gamma rays does not change one element into another element. Key concept check. What happens during radioactive decay? Uses of radioactive isotopes. The energy released by radioactive decay can be both harmful and beneficial to humans. Too much radiation can damage or destroy living cells, making them unable to function properly. Some organisms contain cells, such as cancer cells, that are harmful to the organism. Radiation therapy can be beneficial to humans by destroying these harmful cells. Ions. Gaining or losing electrons. What happens to a neutral atom if it gains or loses electrons? Recall that a neutral atom has no overall charge. This is because it contains equal numbers of positively charged protons and negatively charged electrons. When electrons are added to or removed from an atom, the atom becomes an ion. An ion is an atom that is no longer neutral because it has gained or lost electrons. An ion can be positively or negatively charged depending on whether it has lost or gained electrons. Positive ions. When a neutral atom loses 1 or more electrons, it has more protons than electrons. As a result, it has a positive charge. An atom with a positive charge is called a positive ion. A positive ion is represented by the element symbol followed by a superscript plus sign. For example, figure 16 shows how sodium, Na, becomes a positive sodium ion, Na+. Negative ions. When a neutral atom gains 1 or more electrons, it now has more electrons than protons. As a result, the atom has a negative charge. An atom with a negative charge is called a negative ion. A negative ion is represented by the element symbol followed by a superscript negative sign. Figure 16 shows how fluorine, F, becomes a fluoride ion, F negative. Key concept check. How does a neutral atom change when its number of protons, electrons, or neutrons changes?